So in 4.7, we are talking about inverse trigonometric functions, and we're splitting this up into 2 days. Here we go. So on the first day, we're going to evaluate the graphs of the inverse sine functions and graphs of the other inverse trig functions, so your sine or your cosine and your tangent, and then we'll look at compositions of trig functions. So remember, thinking back to inverse functions, that's when we switch the x and the y and then we solve for y. In order for a function to have an inverse, it has to pass the horizontal line test. So when you look at this graph of your sine function, it doesn't pass the horizontal line test, right? If you were to draw a horizontal line through here, it would pass through more than once. So it would fail that horizontal line test. So what we have to do in order for sine to have an inverse is we have to restrict it to just this little portion of the graph from negative pi over 2 to pi over 2. So if we restrict the sine function, then just that little portion does have an inverse and it does pass the horizontal line test. So what we have to think about is that with our inverse sine function, and we'll get into this notation in a minute, but your inverse sine function is always restricted from negative pi over 2 to pi over 2, which means all of your answers will fall in that range. Okay, and your sine function that is always increasing, it takes on that full range of values from negative 1 to 1. And by restricting it, we make it 1 to 1. And remember, 1 to 1 means that your function passes the vertical line test and the horizontal line test. So a couple different notations when we're talking about inverse. We have the y equals the inverse sine of x. So that's probably the notation that you're more familiar with. But one other thing that you'll see is y equals arc sine of x. And they both mean that we're finding the inverse of the sine function. And when you find the inverse, it means that you're finding an angle measure. Okay, so anytime you're finding the inverse sine of some value, you're always solving for an angle measure. All right, so let's work on evaluating these inverse sine functions. And again, we're solving all of these will equal some angle measure. And that angle measure, remember, is restricted for our sine has to fall between negative pi over 2 and pi over 2. So it has to fall somewhere in that range. And so something you're going to have to think about is your unit circle, or maybe you'll have your unit circle in front of you. Okay. So I'm going to do a green path here, which means like this is the path that you need to stay on. So you can go from 0 to negative pi over 2. Your answers could be anywhere there, or they could be from 0 to pi. But you can't ever go off that green track to get to your answer. So for this first one where it says arc sine is negative 1/2. So that means really that the sine of some angle measure equals negative 1/2. So somewhere on the unit circle, the sine is negative 1/2. So that would be your y value is negative 1/2. So it would be right here. Okay. Most of you will want to go, I'll keep it in yellow, will want to go this way around the circle to get there. So you would say, oh, we're going to go positive pi over 11 pi over 6. But the issue is that in order to get there, you went through this area over here, which was outside of the domain. So you can't go all the way around to that spot. So the way that we're going to get there is we're going to go from 0 and we're going to go a negative direction. So we're going to say the answer here would be negative pi over 6. We'll do the same thing for part B. So we'll say the sine of theta equals root 3 over 2. So you have to think, when does the sine equal root 3 over 2? So that's up here. So we're looking at this point up here. And so from here to here, the sine is root 3 over 2 at pi over 3. So then the last one is that, again, if we were to rewrite this, the sine of theta equals 2. Well, 2 isn't a value that you have on your unit circle. So that would be one where in your calculator, you're going to type second sine, right? Second sine of 2. And when you do your second sine, it gives you that sine inverse of 2. Make sure you're in radian mode. So when you do the inverse sine of 2, you get an error, right? And the reason that you get an error is because there's no place when we look here, this is saying that somewhere on your unit circle, the sine will equal 2. And we know that our unit circle, the sine can only equal a maximum of 1. So this has no solution. Right, so if we're trying to take the inverse sine or inverse cosine of a number greater than 1, it's not going to work because the values don't go beyond 1 in your unit circle. All right, if we look at this next example, if we were graphing the inverse, what we could do is if you made a table, so if you almost thought about this as being your sine of x and your y, right? So the sine of pi over 2 is 1. The sine of pi over 4 is root 2 over 2. Then all you have to do for your inverse then is we switch. If you notice, they just switched the x and the y. So these points that were on your sine graph that gave you this graph, then what you can do is you switch them and you redraw them where your x's and your y's are switched. And so then this function over here becomes the inverse. So the most helpful way to do that is probably to draw a table or to look at a table for those values using your unit circle. All right, so then we also have cosine. And again, cosine function is not one-to-one. So what we have to do is we have to restrict cosine, right? But we can't restrict it from negative pi to 2 to pi over 2 like we did for sine because it's not one-to-one there. So cosine is restricted from 0 to pi. So you have to remember that cosine values, when you're finding the inverse, have to fall between 0 and pi, the same way that sine had to be between negative pi and 2 to pi over 2. Okay, so again, you can have your arc cosine, or you could have your inverse cosine. And you have that table, right, where if we had said that this was originally your cosine of x and this is your y, then when we find the inverse, we switch that x and that y value to help us graph those inverse functions. So inverse tangent has an interval from negative pi to 2 to pi over 2. Because if you think about your tangent graph, right, tangent's not defined at negative pi over 2 or positive pi over 2. Those are where those vertical asymptotes are for your tangent graph, which is why if you notice right here, we have parentheses and not brackets because we're not including that. And so really just one of those arms of your tangent graph is what we're restricting, because if we just looked at one little part of that tangent graph, then it would be one-to-one, right? And then we have that table of values, right? So here, what we need to remember, this is really what you need to remember. These are kind of your restrictions where all of your answers have to fall. So this, your inverse sine, all of your answers are between negative pi to 2 to pi over 2. Your inverse cosine, all of your answers will be between 0 and pi. And your inverse tangent is the same as your inverse sines when you're looking at that unit circle. All right, so let's look at example 3. We have a couple tangents. So again, remember, whenever we're finding the inverse, we're looking for those angle measures on the unit circle that correspond. So for part A, we're looking for the cosine of theta has to equal root 2 over 2. So let's just sketch real quick a unit circle. Right, and cosine, remember, is restricted Your inverse cosine is restricted from 0 to pi. Okay, so if we put our green track from 0 to pi, so our answer for cosine has to fall between 0 and pi. So then we ask ourselves and we say, self, when does cosine equal root 2 over 2? And when we look at our unit circle, our root 2 over 2 is right here at pi over 4. Right, so this would equal pi over 4. So the cosine is root 2 over 2 at pi over 4. This one is saying cosine of theta equals negative 1. So when does cosine equal negative 1? Well, that's over here. And so your answer would be at pi. Right, when we have our inverse tangent, again, we're talking about the tangent of theta equals 0. Or for part D, the tangent of theta equals negative 1. And remember, tangent is sine over cosine. So in this case, in order for tangent to be 0, really your sine has to be 0. So let's think again about our unit circle, because tangent is restricted, like the same as sine. So right, tangent goes from negative pi over 2 to positive pi over 2. So tangent would be 0 when sine is 0, which is at 0. So this answer would equal 0. Tangent's negative 1 when sine and cosine, when you're dividing those, is the same. So sine and cosine are the same at the pi over 4s, but it needs to be negative. So we're here, and we have to go in this direction, right? We have to stay on that track. So we would be at negative pi over 4. Okay. You have to know your unit circle. Like, you just, at this point, you have to be familiar with your unit circle and really know those values. So I would tell you, if you don't have your unit circle memorized, like, that's really something that you need to have memorized at this point. When we're in person and we're taking tests and quizzes, you will not have a unit circle in front of you. So when we're looking at compositions of functions, if you have a function and its inverse, and x is in the domain, then your answer will just equal x. The same thing with an inverse function of a function, you'll also get x. So keep in mind, though, that if we have, in this case, arc sine, which is like the inverse sine of the sine of 3 pi over 2, your answer is not 3 pi over 2, because 3 pi over 2 isn't in that domain for inverse sine. Because remember, inverse sine, all your answers have to be between negative pi over 2 to pi over 2. So what happens there is your answer, you would say, okay, well, my answer is 3 pi over 2, right? Because these, in a way, cancel out. But to get to 3 pi over 2, you have to go all the way around your circle to right here. And in your inverse sine, you're only allowed to go from here to here. So we can get to that point, but the way we get to that point is we would actually say we go negative pi over 2. All right, so let's find these inverse values. So first one, tangent. I don't love when they have the arctan, so sometimes I rewrite that just as an inverse tangent of negative 5. And I know that negative 5 isn't something that I know from my unit circle. And tangent, remember, is restricted from negative pi to 2 to pi over 2. But because tangent goes to plus or minus infinity, you don't have that negative 1 to 1 restriction. So when you have the tangent of the inverse tangent of negative 5, if you type that into your calculator, you just end up with negative 5. Okay? So here, where we have the inverse sine of the sine of 5 pi over 3. Now 5 pi over 3 is way over here, and you have to go all the way around to get to 5 pi over 3. So what you need to think about is, because we can't go all the way around, how would you get there going in the direction that you're allowed to go. So just going from here to here. What's that value, right? So the inverse sine of the sine of 5 pi over 3 is actually negative pi over 3. Okay? Another way to think about this, if we did the inverse sine of the sine of 5 pi over 3, we can also do this in parts. So the first thing we can say is we can just do what's in the parentheses. We can solve for the sine of 5 pi over 3, which is just a value on your unit circle. So if we have the inverse sine, the sine of 5 pi over 3 is negative 1/2, right? So now your equation is the inverse sine of negative 1/2, and we know then that we're looking for an angle measure. So on that restricted domain, when does a sine equal negative 1/2? And that's where we're at negative pi over 3. So if that makes it easier, we can do the same thing here. We have the cosine. If we just did the inverse cosine of pi, we would say, when does the cosine equal pi, right? So the inverse cosine of pi. Okay, so if we said, well, when does the cosine equal pi? So this right here is saying like the cosine of some angle measure is pi. But remember that rule we have that with sine and cosine, this one can only go up to 1. So the cosine will never equal pi. The cosine of pi has a value. So with part C, there's no solution. And again, if you type it into your calculator, you'll get a domain error for that. All right, so then we have this last one. That's a composition of functions. And with these, we don't have values for like negative 2/5 and 2/3 on our unit circle. So first let's start with if we have the cosine of the inverse tangent of negative 2/5. So we're going to kind of break this apart. So this was a composition of two functions. So we're going to start just by looking at this inside function. And remember, when we're finding an inverse, we're finding an angle measure. So this whole problem is really just asking us to find the cosine of an angle measure. But they're telling us that that angle is the inverse tangent of negative 2/5. Okay. And so if we were to rewrite this, we could say that the tangent of theta is negative 2/5. Okay. And remember, we had the inverse tangent. So your inverse tangent is restricted, right, to just that first and second quadrant. So let's think back to when we were drawing triangles. The tangent is the opposite over the adjacent. So what we can do is we can actually draw a triangle. If tangent's negative, it's going to be in the fourth quadrant, where the opposite side is negative 2 and the adjacent side is 5. And so then the hypotenuse, using Pythagorean theorem, is the square root of 29. And so now if we go back to say, well, this problem is just asking us to find the cosine of theta, where for this triangle, and the cosine of theta is the adjacent side over the hypotenuse, right? Which if we rationalize, we get 5 root 29 over 29. All right, so let's do the same thing for part B. Use a different color. So again, this is an inverse cosine of 2/3. So this is really saying find the sine of a theta, because whenever we solve for an inverse trig function, we're looking for an angle. But they're telling us that the angle is the inverse cosine of 2/3. So if we were to rewrite that, we could say the cosine of that angle is 2/3, right? And cosine is the adjacent over the hypotenuse. And cosine, for inverse cosine, we're restricted to the first and second quadrants. Cosine's positive in the first quadrant, so we would draw our triangle in the first quadrant. The adjacent side is 2. The hypotenuse is 3, right? Which makes the opposite side the square root of 5. And then if we go back to this equation that we wrote, I would always recommend writing that equation, because you go back to that and you say, okay, well, it's really just asking me to find the sine of theta for the triangle, and the sine of theta is opposite over hypotenuse.